Many say the lab could be stripped of all its defense contracts, contracts which make up 2/3 of Livermore's budget. Tonight, Channel 7's Brian Hackney joins us with part 2 of his in-depth look at the future of the lab. Brian?
Well, Richard, it's been called the Bay Area Brain Trust. Over 9,000 top-notch researchers from every scientific discipline working together in one place. But if Livermore loses its military mission, the question is, what do you do with all that brain power? This diamond-turning lathe is one of the most precise machine tools in the world. It may also be one of Livermore Laboratory's best hopes for survival. Tech transfer is one key to Livermore's future.
The technology that built machines like this can be applied to the private sector and the manufacturing industry, which is going to tighter and tighter tolerances all the time.
Streams of oil lubricating the lathe's surface are kept at a temperature so constant it never varies more than 1/100th of a degree Fahrenheit.
You can increase the accuracy of a machine simply by controlling the environment.
How precisely can it slice?
1/600th of a width of a hair, so 600 times smaller than the width of your hair.
Such accuracy was essential for machining parts for nuclear weapons. Soon it may help slice wafer-thin computer chips, because Livermore's technology is now on the market.
It's available to anybody that's interested out there.
I know today that the world's finest makers of swords can and will be the world's finest makers of plowshares.
In a post-Cold War world, Livermore must reinvent itself. One option is to convert from military nuclear weapons to civilian research and development. For instance, lasers, first designed for Star Wars, will soon shape autos on a GM assembly line. And Cermet, a ceramic metal alloy first designed for armored tanks, may soon become high-strength golf clubs. With dual-use technology, Livermore Lab is forming cooperative research and development agreements with private industry.
A year ago, we Livermore had zero cooperative research and development agreements. Today, we've got over 80.
In most cooperative agreements, a business pays for its personnel, while the Department of Energy pays for Livermore's researchers, lab space, and equipment. Some are split 50-50, but high-risk ones can be 80-20, with the government picking up the difference. As part of the bargain, a company gets exclusive patent rights for 5 years, and lab scientists can now get royalties for their inventions up to $20,000 a year. But some question the whole concept of spending tax dollars this way.
We don't want to see the lab becoming just a sort of welfare handout for the Fortune 500 companies.
Others see this as an investment in American economic competitiveness.
The money's already been spent, essentially, so the minor amounts of money to facilitate technology transfer is a very, I think, a wise investment.
A congressional study on technology transfer revealed that 85% of the research done by Japan's equivalent of federal laboratories is available to industry there. In both Europe and Japan, the prime purpose of government labs is to develop new technologies for business. Japan actually spends 1/3 more of its gross national product on research and development than the United States. But business analysts are quick to point out Livermore Laboratory is still not a thoroughly comfortable business partner. One problem is the secrecy. Every few feet, visitors must pass through rigid checkpoints, and in most buildings, visitors are greeted with intimidating signs. And some researchers acknowledge lab personnel are not used to business deadlines, budgets, and economics.
I have to confess that I just haven't thought in those terms.
There's no question that the lab people are not in any way familiar with market forces.
As for being a new mission for the lab, Livermore's current budget totals $1.1 billion a year. The lab's 84 cooperative agreements only add up to $50 million. Many in the lab believe the technology transfer may not be enough to keep all 9,000 workers here employed. So they have a different idea. It was first proposed by the Energy Secretary. And that is, why not turn Livermore into a green lab? That is, have it dedicated to solving the country's energy and environmental problems. Many scientists here say there would be plenty to do.
We think there's probably enough work in the state of California to keep us busy without looking at the rest of the country.
With respect to energy and environment alone, there are far more problems that the country needs solved that could possibly be worked on intelligently by this lab alone.
For starters, our nation's Superfund sites. Hunters Point Naval Shipyard is one of many toxic dumps created by the U.S. government, sites Livermore could help clean up. This bacterial soup may be one of the answers. In vats of methane, pollution-loving microbes are multiplying. Soon they'll be pumped underground into contaminated groundwater, where they act like biofilters. As a plume of polluted water flows past the bacteria, they eat contaminants such as TCE, one of the major chemicals found at Superfund locations.
We can achieve more or less complete degradation of the TCE from moderate strengths to below our detection limits.
Livermore is working on other pilot programs, from gasoline recycling to fiber optic pollution sensors.
We could easily become a green lab and do very, very challenging science and technology.
So you've got a mission, and I think the environment could be the thing of the future for the lab.
I think he's right. What's the plan for tomorrow? What are we going to see tomorrow?
Well, the first two parts we've been talking about the future of the lab. What are they going to do next? But tomorrow night, you know, there are people in Washington who say the lab is not going to have a future unless it overcomes the waste and management mistakes of the past. We'll talk about those and about the plan for the future tomorrow night.
Okay. Thanks, Brian.
Martin Wine.